Geology and Non-Renewable Mineral Resources. Chapter Overview Questions. What major geologic processes occur within the Earth and on its surface? What are non-renewable mineral resources and where are they found? What are rocks and how are they recycled by the rock cycle? How do we find and extract minerals resources from the earth crust, and what harmful environmental effects result from removing and using these minerals? Core Case Study: The Nanotechnology Revolution. Nanotechnology uses science and engineering to create materials out of atoms and molecules at the scale of less than 100 nanometers. Little environmental harm does not use renewable resources. Potential biological concerns can move through cell membranes. Geologic processes. The Earth is made up of a core, mantle, and crust and is constantly changing as a result of processes taking place on and below its surface. The Earth's interior consists of core, mantle, crust. Core is innermost zone with solid inner core and molten outer core that is extremely hot. Mantle, solid rock with a rigid outer part that is melted pliable rock. And lastly, the crust, outermost zone which underlies the continents. Geologic processes. Major features of the Earth's crust and upper mantle. The Earth's core mantle crust, tectonic plates, lithosphere surfing, collision between two continents, oceanic tectonic plate, spreading center, oceanic tectonic plate, ocean trench, plate movement, ocean trench, mantle, mantle convection cell, material cools as it reaches the outer mantle, material rising through the mantle, cold dense material falls back through mantle. Two plates move towards each other. One is subducted back into the mantle on a falling convection current. Hot outer core, inner core. Geologic processes. Huge volumes of heated and molten rock moving around the Earth's interior form massive solid plates that move extremely slowly across the Earth's surface. Tectonic plates. Huge rigid plates that are moved with convection cells or currents by floating on magma or molten rock. The Earth's major tectonic plates. The Earth's major tectonic plates. The extremely slow movements of these plates cause them to grind into one another at convergent plate boundaries, move apart at divergent plate boundaries, and slide past at the transform plate boundaries. Geologic processes. The San Andreas Fault is an example of a transform fault. Wearing down and building up the Earth's surface. Weathering is an external process that wears the Earth's surface down. Minerals, rocks, and the rock cycle. The Earth's crust consists of solid and organic elements and compounds called minerals that can sometimes be used as resources. Mineral resource is a concentration of naturally occurring material in or on the earth crust that can be extracted and processed into useful materials at an affordable cost. General classification of non-renewable mineral resources. The U.S. Geological Survey classifies mineral resources into four major categories. Identified, known, location, quantity, and quality or existence known based on direct evidence and measurements. Undiscovered, Potential supplies that are assumed to exist. Reserves identify resources that can be extracted profitably. Other undiscovered or identified resources not classified as reserves. General classification of non-renewable mineral resources. Examples are fossils, fuels, coal, oil, metallic minerals, and non-metallic minerals. Geologic processes. Deposits of non-renewable mineral resources in the earth crust vary in their abundance and distribution. A very slow chemical cycle recycles three types of rock found in the earth crust: sedimentary rock, sandstone, limestone; metamorphic rock, slate, marble, quartzite; igneous rock, granite, pumice, basalt. Rock cycle. Environmental effects of using mineral resources. The extraction, processing, and use of mineral resources has a large environmental impact. Natural capital degradation. Environmental effects of using mineral resources. Minerals are removed through a variety of methods that vary widely in their cost, safety factors, and levels of environmental harm. A variety of methods are used based on mineral depth. Surface mining, shallow deposits are removed. Subsurface mining, deep deposits are removed. Open pit mining. Machines dig holes and remove ores, sand, gravel, and stone. Toxic groundwater can accumulate at the bottom. Area strip mining. Earth mover strips away overburden and giant shovels removes mineral deposit. Often leaves highly erodible hills of rubble called spoil banks. Contour strip mining, used on hilly or mountainous terrain. Unless the land is restored, a wall of dirt is left in front of a highly erodible bank, called a high wall. Mountain top removal. Machinery removes the tops of mountains to expose coal. The resulting waste rock and dirt are dumped into the streams and valleys below. Mining impacts. Metal ores are smelted or treated with chemicals to extract the desired metal. Supplies of mineral resources. The future supply of a resource depends on its affordable supply and how rapidly that supply is used. A rising price for a scarce mineral resource can increase supplies and encourage more efficient use. Supplies of mineral resources. Depletion curves for a renewable resource using three sets of assumptions. Dashed vertical lines represents times when 80% depletion occurs. Supplies of mineral resources. New technologies can increase the mining of low-grade ores at affordable prices, but harmful environmental effects can limit this approach. Most minerals in seawater and on deep ocean floors cost too much to extract, and there are squabbles over who owns them. Getting more minerals from the ocean. Hydrothermal deposits form when mineral-rich, superheated water shoots out of vents in solidified magma on the ocean floor. Using mineral resources more sustainably. Scientists and engineers are developing new types of materials as substitutes for many metals. Recycling valuable and scarce metals saves money and has a lower environmental impact than mining and extracting them from their ores. Case study: the eco-industrial revolution. Growing signs point to an eco-industrial revolution taking place over the next 50 years. The goal is to redesign industrial manufacturing processes to mimic how nature deals with waste. Industries can interact in complex resource exchange waves in which waste from manufacturing becomes raw materials for another.